In the second part of this lecture, we will look at how we create now arrays of students' name. So we had this list of names of students before, but what happens is that some of these students are in my morning 2 to 9 session and other students are in the afternoon session. So let's say that those are the students in the morning sessions and those are the students in the afternoon session. What I would like to do is to create an array of the addresses of the strings of the students in the morning session and create another array that contains the address of the strings of the students in the afternoon session. The address of a string is the address of the first character of that string. So for example, if I'll create an array with my students in the morning session, the first position of my array will contain the first character of the name Veronica. And the second position of my array will contain the address of the first character of Xinmei, and the third position of the array will contain the address of the first character of Malcolm. So the most important thing to remember is that these arrays that I will create, each element of those arrays will be a memory address, and it will be the memory address of the first character of each string. So for example, my array will be somewhere else in memory. Of course, I will allocate some space in memory for my array. And the first position of my array will be the address of the character V in the name of Veronica. The second position of my array will contain the address of the character X in Xinmei, and so on. Now, when I finish to list all the addresses that I have for all the students in one session, I would like to have a sentinel value. I like to have a value that tells me that that's the end of the array. So I will insert into the array the number -1, that is 0xFFFFF. And then I can, right after that, start the array for my next session of my classes. That will be my A2 session. So this is the array of this is an array of pointers to strings, and this is the sentinel value. So now I'll create my second array. The first address in the second array is the address of Hao Chan's name, and then the address of Sunny's name, and the address of Taylor's name. And finally, I have a second sentinel. So this is the way that I want to organize my data in memory. This way, if I wanted to print, for example, all the names of all the students in one of my sessions, I can just have the address for that session, for the array for that session. And so I could start, for example, a function with this address here that will tell me where is the first address for a student name. And I could just scan this until I find the sentinel, and I would have printed the names of all the students in my morning session, for example. So here's a quiz that we could have in an assessment in 2 to 9. I could ask you to write RISC-V assembly code for the function maxlen. What the function maxlen does, it takes as a parameter the address of the first pointer to a name in a class. So for example, this function could take this address here, or could take this address here, depending on which session of the class that I wanted to print the max length, that I want to obtain the max length for. And the return value will be the number of characters in the longest student name in that session. So what maxlen will look like, so first note that the parameter for maxlen is of type char star p, because this what I'll pass to maxlen would be, for example, this address here, and the memory location in that address contains. So this says that this is a pointer, And inside that memory location, I have another pointer. So you can read this as a pointer to a character. And that's why you have the star star. So you read this as P is a pointer to a character. Now, I need a local variable that I'll call maximum, and I'll initialize maximum to 0, so assuming that I may have a null string in my list. And now what I'm going to do is, while I don't see the sentinel, I'll pass to string length the address of the first character of a string. So what I have to pass to string length is star p. Star p means the content of p. So p is the variable that is at this memory address here at 103000. Star p is the value that is inside that memory location, and that value in this case will be 0x10010000. So I pass in the address of the first character of a string to string length. That is what we string length expected. We wrote string length the first part of this lecture. And then I'm just gonna test whether the value returned by string length is greater than maximum. If it is greater than the maximum, then this is my new maximum. And then I will increment the value of p. So in this case, if I started in this position, incrementing the value of p will gonna move me to the position 103004. So this is how the max length will gonna work. In the end, I'm gonna return the value of the maximum. So here's max length. And I will start by making a copy of p into S0. The reason I'm making a copy of p in S0 is because remember that the argument for the max length, the first parameter, is in A0. And I'll have to put the value of star p into A0 to call string length. So I'll be overwriting A0 with a new value. So I must preserve the value of p if I wanted to be able to increment it after I call string length. That's why I start by making a copy into S0. Next, I will zero the value of maximum, and I'm going to use S1 for the value of maximum. The reason why I'm using S registers and not T registers is because I am about to code a loop. In this loop, it has a function call. If I were to use T variables in a loop that has a function call, the callee could change the value of my T registers. So I'm better off using S registers here, so that the alternative would be for me to use T registers and then start saving and restoring the values of the T registers right around the call to string length. But then all that saving and restoring would be inside a loop, and it would be much more expensive than the saving and restoring that I'm going to have to do in max length. I'll initialize the sentinel. My sentinel is -1. And now I will start the execution of my loop. Inside my loop, the first thing that I need to do is to load the value from, to obtain star p. It's a load from p into a variable. In this case is A0, because I'm going to be passing this to string length. But after I do the load and before I call string length, I need to test it to see if this is the sentinel. So I ask whether star p is equal -1. If star p is equal -1, I am done and I'm going to be going to the end. Otherwise, I'm going to call the function string length, and I'll pass to string length the value of star p. So it's very important that you remember that when I have star p, that translates to a load word from that variable. Next, I increment the pointer. This is a pointer to a pointer, and in C, a pointer has 32 bits. A pointer is an address. So this is a vector of addresses. So each element of this vector contains 4 bytes. That's why I have to increment by 4. Next, I'm going to ask whether the new value that I got for t from string length is less or equal than maximum. If it's less or equal than maximum, I don't need to do anything, and I can simply go and get to the next position of my array of addresses. However, if it's not, if I just got a new maximum, then I have to copy this new maximum into my maximum variable, and after that I can go back to my next position of my vector of pointers. And in the end, I simply copy the value that's in S1, that's my maximum, into A0, because I always return a value into A0 when I return from a function, and then I return. So this is my max length function. Note that I would have to save the values of S0, S1, S2, and array, because there is a function call in the middle of this loop. So I would have to save those values in the beginning of max length, and I would have to restore those values right before the return statement. Because this slide is too small and I don't want to make the font so small, I omitting the saving and restoring code from this slide. But you know that you need that code in order for the code to be the function to be correct. So now let's see how this function works. So before I call max length, another function, the caller to max length, has put the address of the first position of my array of addresses into A0. So this is indicating that I wanted to find the max length for the session of my classes that is in this area of memory. So the first thing that I need to do is to make a copy of A0 into S0. And then I need to zero my maximum. And I'm not going to track S2 because S2 all it contains is the FFF value. Oh, and let me move myself. Sometimes it's hard to see what's